Veronika,
right.
please introduce yourself.
Hello, I'm Veronika Lawrences. I work at T-Systems as a cloud consultant. And I'm glad to be here. It's my first conference, so please be gentle.
And my name is Bernd Rederlechner. I'm the lead architect of cloud in systems integration, which is the part of T-Systems who makes the projects for customers and uses the platforms that we also sell on the other side, like Open Telecom Cloud. And since a few weeks, I'm also officially announced as one of the 10 chief technologists of T-Systems. So also be gentle to me because I don't know what this job even means to me. So just be aware that if I say something, don't take it too serious because I'm just a chief technologist. So, okay.
Yeah.
Okay, let's start.
So there's still some seats over there if you wanted to sit down. Well, the microphone is for the video. So I'm sorry if I try to talk louder.
Give it a cry.
Yeah.
Okay. So today we want to show you our thinking about DevOps and what we think is really, really at the heart of this whole movement that we are talking about, which is much, much bigger than only putting some dev people and some ops people in a room and thinking that they bring up something very, very special and very, very fast. And whatever you think of this miracle that should occur in this room, it isn't. What in the core, the movement of DevOps has started with something very different. And I think you need something that stops you from thinking in the old way first. And one of the indicator that you may think a little bit old style is this one-shot thinking, which is depicted here with the bullseye thing. And many, many things that are still done, and be it produced with Scrum, be it produced with Waterfall, be it produced whatever, has still intrinsic the thinking of, I have to produce something in one shot, and I have only one shot, and then I must be done. And this, combined with the fact that we only can deliver 2 or 3 times in big organizations per year, makes a very, very insane combination of things, because this means you have only 2 or 3 times training to deliver something. And you have to deliver it in one shot. And if you think about how humans work, human error is a natural part of our being. So you have to be prepared that you make human errors. And if you can only, and don't believe in any way that you can deliver anything in one shot. What DevOps now says is, please approach the delivering of things, the delivering of IT differently. Everybody says, okay, let's start with iterations, but the thing is bigger. And the thing has already started a time ago in 2000 when we started to produce the Agile Manifesto. And now we have to put all the things together that we've already done and make it and bring it to a mechanism that helps us deliver value at speed. And if you look at the colors have a meaning in this. We call it infinite band. It means you have to continuously go through these phases, and that these are not phases in the sense of time phases, but method phases. You have to apply, to go once through all methods in all of these different phases for one iteration, and we will explain later what this means than iteration. It's a little bit different than it has been before. If you look at the blue part, the define, develop, and integrate part, we know this thing already very well for a long time. The interesting observation about this is a part where you have to get creative. You have to find methods to bring people to the point where they can creatively produce things. And for this, we are, meanwhile, in my thinking, very, very well. We have a lot of tools, we have a lot of methods to go with Scrum, to make backlog management, and so on, so on. So I think we have, in the last 10 to 15 years, very well understood how to produce creative things and produce and make ideas reality, which is creativity all about. But then, and this is the point where DevOps has started, is then we are terribly slow to deliver the things. And we thought about what is the next step? And it's not our thought. It's simply a summary of all the things that you read in the DevOps community. If you read the Phoenix project, if you read Jess Humble and his continuous delivery, it's just a condensation of what they've written, what we try to put in this loop here. The profound thing that you found out for the deploy, test, and release stage is the purpose of these stages is not producing something which is art, which is every time different. The only thing that you have to do in this part of the delivery process is you have to deliver reliable and repeatable. This very, 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 very basic. If you push the button to deploy, the deployment should work. Nothing more and nothing less. And you should have not care anybody. There should be no alignments. There should be no approvals, nothing. You push the button, and the thing is deployed in production. Which means we are talking about something we also very well know for a long time, which is industrialization. And industrialization, we also have many, many tools, and we can borrow many, many ideas from Lean, for example. And now it becomes even clearer what you have to do with Kanban. Kanban is the control mechanism for industrialization. And you should use it in this way, not think about how should I use Scrum boards or Kanban boards or whatever. This is not the point. The point is you have a part where you industrialize, and this part you can use Kanban to control the flow. And finally, and this is the interesting part because it's the upcoming part of in the DevOps community at the moment, you need at the end a phase where you observe the system. It becomes very, very clear as soon as we are talking about empirical research why you have to have these phases. And before knowing what empirical research is, you have already observations about these phases because you have these phases already as soon as you get really in trouble in production. Because what then happens there is somebody has to find out that you're in trouble in production, which is the feedback part. And then you need a task force which does the analytics and find out what really, really is about the problem in the system, and you learn what's wrong. This is an analytic challenge, and in this phase you work analytically. You need people who can derive causes from facts, nothing else. And even for this there are methods there, and you should take a look at these because maybe these help you immediately more than any automation or any other things you can see. And in the core, what happens is we wanted to find out what is really the difference in thinking you have to do when you go to with DevOps. And we think that we always have left out something that is done in research naturally in science. All the time I can think of about, when I learned about science, this was always the way how science goes. You make theoretical research, where you derive your formulas, make your ideas, and your model of a reality. And then you're not done. So the relativity theory of Einstein was not done with deriving the formulas. But the second part is still ongoing, which is empirical research, which means you go for a practical research where you make experiments and try to prove that the model of the reality that is underlying the theory, relativity for example, really applies to the reality, or whether you have forgotten a certain fact which means you have to adapt your theory, your hypothesis. And this is the way DevOps works. DevOps is all about experimentation and finding out whether hypotheses work. So requirement is not a law anymore. You have to implement and then you are done because you have followed the law. It is just a hypothesis and you have to invent experiments in your system to find out whether it really applies to your customer or not. And you will be really, really embarrassed how often you find out that you have overseen facts which are very trivial as soon as a customer looks at your system. It is difficult to understand, and it's very, very theoretical what I explained so far. But we wanted to have something which goes viral, and this is the white elephant. And I want to tell you what I think is the classical way of doing the things, and Veronika will tell you what you should do. So, this is the plan, build, run. We added test because we need it, but it's here. This is the phase as you go. And how does software development work today? Somebody comes and says, let's build a white elephant. And maybe he tells you for heavy lifting, but even I've seen many, many times, they even don't see why it is done at all. And somebody builds a nice, fancy specification. It has to be a feature complete elephant to have the one shot to the goal. And it looks like this. Interesting is especially the steering wheel. Somebody has decided that everything you drive has to have a steering wheel. Okay, the elephant has a steering wheel. Fine. Then we make something like technical design, which in the very, very core is nothing else but a divide and conquer strategy. You just cut your thing in small pieces by some technical criteria and get a cut elephant. And of course, the steering wheel has to be there, clear. And we call this design. Then the time comes, because it's a feature-complete elephant and it's very big, and you may overestimate what you can do in the short time you have. You for sure come to the point where that, okay, time is running out, we have to reduce the elephant. And because it is cut down, you just make some discussions about the pieces and decide this piece, not this piece, this piece. And of course, because the steering wheel was so easy, the steering wheel stays in because it's already done. And some things are smaller, for example, the headset. And yeah, do you see already the problem? No. I see it already. I know what the problem is. Then we put the elephant back together, because we want to have the acceptance test, which is more or less a test which says, okay, we've made some manual test on the elephant and it looks good. It looks like an elephant. It seems like, and the specification is an elephant, so it seems to be okay that the elephant goes. And the elephant goes to production. And then the criteria, whether the elephant stays or not, is simply, as long as nobody complains, the elephant stays. But look, the elephant has a big problem. It never ever lifts any weights. Okay, Veronika, I'm deeply in trouble.
So let's get started with the new way. So I guess most of us have seen elephant projects so far, myself included. But let's have a look at how it could work. So here you see the infinity loop you've seen earlier. We have define, develop, industrialize, feedback, and learn. And if you start, you don't start with, I need an elephant. You start with a user story. And the user story is, I need a tool for heavy lifting so that I can move around trunks in unpassable areas, and I want to be ecologically sustainable.
Ja. Nachhaltig, also ökologisch nachhaltig für Deutsch. Genau.
So I don't want a big truck or something, but I want to be sustainable. Okay, next step is development. You have a smart guy who suggests, let's experiment if an elephant can do the job. And then you have the smallest white elephant possible. And you develop the elephant. And because it's so small and tiny, you never divided up into pieces. You always have the whole elephant in front of your eyes, and you build the complete elephant. And then in the next phase, industrialize. You check, is the rest of the system okay? Can the elephant get into the china shop or no? And if everything is okay, you can say, the elephant can be released. It doesn't break anything else. And now there's the most important phase, which is feedback. Let's have a look at the elephant and see what it does. It's a small elephant, so it can't lift much, but it lifts something and you can count it. So our elephant is lifting and it's doing the thing it should do. And from this experiment, from this confirmation that the elephant does what it should do, you can make a decision. Either you say, okay, the elephant is good, let's keep it and let's let it grow, add further experiments to it. Or if you don't like what the elephant does, you can also say, nah, the elephant wasn't the right solution, let's go back, let's try something else. The most important thing here is you never have the cut-up elephant puzzle. You always stay with the complete context directly in front of your eyes, and you know it does what it should do. So this is a story about value, and for that we need a definition. What is value in the context of software development and delivery? And our definition is a feature generates value if it brings a perceivable and measurable improvement to the end user. So it needs to be able to be perceived by the end user, and it needs to be able to be measured, which is also very important, because it removes all that touchy-feely stuff. You reduce it to numbers. Can I measure it? Yes. So it has value. And with that, I want to go to some anti-patterns, which I've also seen live in projects, some user stories. First, we have a user story. As a developer, I need a functioning development environment so that I can work on the product. So thus, who thinks this user story adds value? Hands up. Nobody? Great.
Yeah. But still the thing is that it does not mean that it's not important, because for the functioning of the team is important, but it is nothing. You
need to do it. No
it is
question.
Nothing which is delivered with the pipeline. It is something that you have to organize internally.
Yeah, it is important. You absolutely need to do it. It is a task, but it is not a user story. It's a developer story, if you want to say it that way. So, second one, as a business person, I need reporting so that I know the development progresses according to plan. Yeah, you've guessed it already. This is also not a user story that brings value. And just to switch things up, the last one, as a customer, I need a checkout page so that I can complete my order. So this is a user story that generates value. And the important thing here is to not lose sight of the context of your product. What are you actually trying to do? What are you trying to build? Which problem do you want to solve? And is a user story, does it contribute directly to the solution of the problem or not? Yeah. Now we come to the core of balance of value and speed. So a functioning DevOps team delivers and runs features with value very often and very fast. This is the goal of DevOps as I understand it. So and the result is, why are we doing this? We want to have satisfied users, happy customers, and we want to be competitive. We want to be fast on the market. In a way, this is just like driving on a mountain road. You have a certain speed, you can drive with a certain speed, and you can be sure to reach your goal eventually, but sometimes you need to change direction. So this is the ideal world. In the reality, there's often problems. So one thing is, you can be driving downhill. Then you will be very fast. If you go off-road and just drive downhill, you will be very, very fast, but you can be sure to never reach your goal. And if we transfer that to the software delivery world, it's being very fast at delivering features that don't have value to your users, to your end customers. And the result is you have a great product, it's very up to date, all of the most current bells and whistles, but in the worst case, nobody wants to use it. The other pitfall is you try to be faster at your goal and you go off-road and you try to get up the mountain directly. This is a problem because your car just can't handle it. And if you transfer it back to the software development world, you get stuck at endless analysis. Are you sure this is the right thing? Are you sure people want that? And in the best case, this eventually results in a product that is also very good, that is what people want. You have done all your homework, but it's too late on the market. And in the meantime, people already use a different product that is very similar and does what your product does. And in order to strike that balance, you need to both keep an eye on your value and keep an eye on your speed. This is what we're doing in the next few slides. How to keep track on value. These are a few questions you need to ask yourself. In the different phases, I have defined feedback and learn because that is where you really can change things you're doing. For define, you need to ask yourself, is there a high probability people want or need to use my product? And also, what is the expected positive effect on the customer? There's your hypothesis. This is your idea you're running with. This is your experiment. And once you've gone through the loop and you've built it, you are running it, then you get to feedback. It's how do I find out that my assumption proves right? How do I know that I was right? This is verification. And you need to think about how do I know that I was right? And also, you need to think about how do I know that I was wrong? So you need to think of verification and falsification at the same time. You need to be sure that you have some indicators that are independent from your verification that prove you are. Because if you only look at the good stuff, if you only look at your verification, you can fool yourself into thinking everything is great. At the same time, you're fooling yourself, and so you need to look at the falsification as well. This is also part of the empirical principle. And at last, when in the learn phase, you can do two things. The first thing is pivoting. If you learned that your experiment didn't work, you still learned something. You know now what does not work, and then you can think about a different feature instead of this one. How can I achieve my goal? What solution do I have for my problem that is different from the one that just didn't work? Or you can think about how can I improve this feature for the users? So let's say you have a feature, the feature is great, functionality is good, but the performance just isn't there and users get impatient and quit. So you can work on performance instead of building a new feature. And the other side is keeping track of speed. And speed is often more about the things you don't do that the things you do. But you can save a lot of times not doing things.
Just very, very profound.
For example, we have another anti-pattern, works as designed. Just a small user story. As a customer, I need a checkout page so that I can complete my order. We already have that one. And every user story also has acceptance criteria. And this one has the acceptance criteria. There is a pay no button. There is an area for the order details. And there are input fields for the customer's address. And this is like having our neatly cut up elephant, and you just check up the pieces. It's there, it's there, it's there. It's complete, should be all right. But you don't know if it works as a whole. And that is why, instead, you formulate your acceptance criteria in a standard format. And this is from behavior-driven design. It has the format of given, when, then. You have, for each user story, you have one or more scenarios where you describe the functionality. First, you give the condition of the scenario. For example, user must be logged in. Then you say what happens. That is an action. User clicks that button, for example. And then you describe what should happen. You describe a potential observation of the experiment. So that when you run the experiment, when you test, you can say, okay, does this experiment work or does it not work? And with that, I move over to my colleague,
Veronika.
And he will tell us about perceived speed.
Yeah. So I think very, very pragmatical what Veronika said. So again, I'm the They sometimes told me Mr. Lean, so I will put even one on top and will tell you something about perceived speed. So don't fear the formula. You will understand it fully in a few minutes. I want to go on a journey with you, a mind journey. And I want you to think about a factory, a car factory. Very simple, because usually if you think about factories, we usually think about car factories. Don't know why. Okay, you have a factory from the outside. You don't look inside. You just look on the outside. And you have two things. You have on the front door of the factory, you have materials that come into that you need for productions, and you have orders which you need for, which say what you have to produce. This is what you observe and what you count. And on the other hand, you see the cars running out of the factory in a certain frequency. Could be very, very streamlined, flown, so every time in the world the same, so every 5 minutes you get a car out. Could be a little bit chaotic. Sometimes a car comes fast, sometimes a car comes slow. But the question is, can you tell something about the speed of the factory just by observing the factory from the outside? And Little's law says yes, and it's very profound that you can do this. And the average lead time is the word you use in DevOps for the time to produce software, from the point where you put your requirement in to the point when it's first used the first time. This is our understanding of lead time. And this lead time, Little says now, is the quote of the work in progress, which is the work you put at the front door and say, okay, please factory, do this work for me. And it is driven by the average throughput of your factory, which can be observed from the outside because you see how fast the cars run out of the factory. And if this varies, the average gives you a good indication about what you perceive about how fast the factory is. Because if you have frequency and you have autos that come fast out of the factory, you have some that come even slower. And if you think about how you perceive things, you usually look at the bad things, which means you even perceive that your factory is slower than the average speed of the factory, because you always look at the worst case things. This thing says, if you want to get fast, you have to control your work in progress. The smaller your work in progress is, the faster is the frequency of your factory. Or taking it the other way, the fewer requirement per deployment you put in a deployment, the faster your deployments will get. Which means that one of the main problems is not automation and how fast we develop, but one of the profound problems in the DevOps world is the speed with which we create requirements and how controlled we put them into the factory. So go to your product owner and think about whether your product owner has ever learned how to control work in progress. This is the main point you have to address first if you want to get that speed. And the second thing is even worse. It says, okay, you can get faster if you optimize the throughput of your factory. Make the throughput higher, which means you get faster. And if you see what the measure of is, it's pieces per second. This is why indeed throughput gets smaller usually. It's a little bit bad in the thinking. But you have to optimize throughput. Just take it this way. And throughput has a bad habit. If you then now really go to the factory and look at what you optimize not the factory, but you optimize the workstations in the factory. And throughput is bad in the sense that it follows the law of the weakest chain. So the weakest part of the chain, which means throughput is limited by the slowest workstation you have in your pipeline. And if manual testing is the one who takes the longest time, so it can make the fewest features per second, not automation is your problem, but testing is your problem. And this is the way you have to analyze, introduce DevOps. You have to attack the bottlenecks. And throughput within the factory has even another bad effect, because if you make too much work in progress, you get queues within the factory. And a non-proven law that adds to the whole fact, which you see on the right side, is that as soon as you have queues within your factory, the throughput even goes down. So will be worse. Which is the profound thing is that if you want to get perceived as somebody who's fast, you have to find out what is your perceived speed from the outside and where are your bottlenecks really within the factory. And maybe you then have not to start with the dev and ops part, but something completely different to get a little bit more speed. Perceived speed for the customer, not speed you think you have internally. Because I think Scrum, meanwhile, is very, very fast compared to 10 years ago. But no one perceives it because you're in a stovepipe and you're fast, but the remaining part of this maybe is not. And then, if you really want to go, you say, okay, automation optimization and all the tools come in. Do you really think that if you're talking about this very profound thing of perceived speed, do you really think that you can improve your perceived speed only by adding tools for each of the aspects that you address in your thing? Because you have to learn a lot new things and have to integrate them and whatever. What would be clear is no matter what you do is, you will have something that diminishes the speed because you care about the tool and not about what you're doing. And so you have to think about what you really need and really look at the bottlenecks. Maybe to get in a delivery frequency of 1 month, you may have to improve only your request production, your interaction with your product owner, and your test stuff and automate it. Maybe you can still work perfectly fine maybe with a manual deployment in this context. And it will go, because you had this frequency of 1 month is something you can reach for sure if you do nothing, which is the classical thing of the classical understanding of DevOps. And this is only the visualization of this fact with how you go with these bottlenecks. You go to your production and you go to your production places, and each of the production places gets one part of the pipeline. And then you measure flow by Kanban, for example, and find out where is the biggest bottleneck. And then you put measures on it. So In this case, test, as it is clearly seen, is the bottleneck, so diminish, first attack the bottleneck of test. Then, second, if this is the way, maybe it's really not a point. The deployments are your bottleneck, but maybe one measure is not enough in this context. So it's still not gone. Even if you have automated your code, you may have to go to a public cloud because you need more environments in parallel. We will address this later. And now we will take a closer look at the teams, because now we know how a little bit how to optimize the outside perception. But now we have to find out why should you put people in one room to get faster.
So I'm sure most of us have already had this situation. We have business people who have requirements, and we have an architect who does a blueprint. And we have service developers who writes acceptance criteria, unit tester who does a test spec, and manuals at the end. And also somebody has to run it. This can happen even when all of these people are sitting in one room. Also, when there's change, I say when, not if, because there's always change. You don't have to change one thing, but you have to change 5 things. So you have 5 times the effort just to stay consistent with your specification. So putting all of the people in one room is only part of the solution. Adding to that, we have Conways Law, which says that every organization recreates in their systems their communication paths. So often, especially in bigger corporations, we have the funny fact that Dev has their tools, Ops has their tools for each of these points. So even for change control, Ops has their own Git and Dev has their own Git, which in my opinion is the biggest sin on this huge list of tool duplication. And there's a tool separations between development and operations, which helps no one. So what do we need? We need a real single source of truth. So this means we have one backlog for everything. One, not one for dev, one for ops. We don't have design stuff on the outside of the backlog. It's all inside and everybody works with it. And from this backlog, code is produced. And in this way, you have a chance to stay consistent and to spare yourself the time and effort spent to keep everything consistent. And also, everybody needs to code. And I know this is kind of confrontational, but what is meant here is there's biz code, which can be in the formula of given then when, which I presented earlier. For example, Cucumber helps with this. There's ops code, infrastructure as code, for example, and test code, and of course the dev code as well. And everybody on the team needs to be able to understand the code of the other people. So you can truly collaborate and point out mistakes. And in this way, you can really force consistency by working code, so that the whole team has one understanding of what we are doing. And with that, we have a little bit more about the value of cloud.
Thank you, Veronika. Maybe to make one point on the code, to make it a little bit more grabbable on it. The thing is that what really changed is that if you produce paper, you don't have checking mechanisms whether what you've written in the paper still applies to the reality. So it's something like a detached from reality thing. And code is a mean to attach reality, which sounds strange at first. but it's very, very easy to think about because the property of code is that it is runnable. And you have a clear outcome. Either it runs or it runs not. And if it has run, because you organize your pipeline the way you have organized it, you said, okay, if it is run and it is checked in, it has also run in production, which means every outcome in production can be tracked to a runnable code, which is a completely different thing, especially if you do security audits or whatever. You don't go to the auditor, and I've been lead architect of the email. I know what it means to go to an auditor because I've done it frequently. In the old world, you go with your paper nicely to your auditor, and the auditor says, here, read it. And then he reads it and says, do you really do it in this way? I cannot believe. Please explain me that make me sure that you really do it in the way it is written in the paper. This is because it's the way with code. You say to him, look, I explain you the code, and I explain you how the code goes to production, and he says, fine, now I see. And he will never ever assume that you do something not exactly as you have written in your document. This is the point. Another thing which is similarly strange as the thing with the code that I've explained before is the value of a real cloud. Because still people think they have a cloud in the basement. I don't want to have a cloud in the basement because I will see anything anymore in the basement because the view is all done. It's gone away because everything is so cloudy. Okay. The question is, why does people say you can only do DevOps using a real cloud? And it is really true, because what you do is, if you want to go to speed and you are a little bit steps further in your improvements and you have found some of the bottlenecks, you come to a point where you have to make the single piece flow into your production pipeline. You have to come over the frontier of 1 month. For example, you want to deliver faster. And then you have to really find out that the release has nothing to do with the deployment. You want to deploy frequently, you want to deploy often, and the best way to do it is only one feature deployed per deployment. But this means not that this means you can do that at any time because it is completely decoupled from your deployment. Because you do two things. You either do dark launching, which means you already deploy parts of your solution into production and as APIs. If somebody uses it, so what? If nobody uses it, also okay, but it's already in production. And the things you visually do, so the things that you really perceive, that is really connected to the customer and has interactions with the customers, you build feature toggles in. And these feature toggles have never worked in the past because of the following thing. If you make a big release and you have many, many features in it, to make really sure that the thing works, you have to test all combinations of all switches. Which is never ever be done, never. You can believe me, never ever be done. Because it manifolds your test iterations you have to do. If you make one piece deployments and you push them with automatic deployment, you have only one switch to test. The one featured switch you put in this deployment, and only with this deployment. And now you can do the following. All things that go in a release are coupled to a switch. And this means suddenly you make a date which has nothing to do with any deployments. You make a date where marketing puts on the switch. Or you put on the switch because you roll out something officially to the customer. And that's all. This is really one of the tricks of DevOps. You have to do it this way. But if you do it this way, you have a hidden problem. And really, for me, this is the speed limitation. To go below 1 month's deployments, you have to do this. And now you hit another bottleneck. The bottleneck are your static environments. And why is this a bottleneck? Because you make so many deployments, and for sure, everybody who does DevOps wants to increase the frequency of deployments. Nobody will tell me he doesn't want to do this. And as soon as you want to do this, you get now waiting queues for your environment. As soon as you have only one test environment, one pre-prod environment, and one prod environment, you get a waiting queue. And the waiting time between two deployments in this scenario is on average 1 day. Believe me, the switch of going to the next deployment, if you're good, you may make it in half a day, but you're not much more. Your static environments become your bottleneck. And this is why none of the really, really grown cloud-native companies and none of the high-speed companies like Netflix, Amazon, or whatever does it this way. And they never told you because this is too deep what you can tell usually on a conference. But if you look at their systems and how the things then really work in production, you will get this. First of all, I have to make the point why it has to be a real cloud. What are the properties of a real cloud? The two basic properties of a real cloud are unlimited resources. So if you have a day shortly before a real release where you give a lot of new features to the customer, you may have a lot of need for tests. And you need a lot environments, which means you need a lot resources. While over the usual weekend, you don't need resources at all. So you need something which gives you as many resources as you need. And this is usually only given by a kind of public cloud. And this is why the leaders all go to public cloud, and the followers now go to also to public cloud, but don't know why. This is the reason why they all go to public cloud. Not because it's so nice and so cool and so much cheaper, because you get parallel environments on demand. And the on-demand stuff is the point, because you can create environments with the push of a button, and don't have to wait until an order is fulfilled and you get your new computer and so on and so on. The self-service and the push of a button is the second part you need for on-demand environments. And the whole kettle then looks like this. This is even a very, very, very conceptual picture of what's really going on in this world. Each time you make a deployment, you start a lot of new environments for performance testing, for security testing, for don't breaking things regressions, and so on, and maybe also even developer environments. And they will be deployed with a push button, they will be run, and they will be destroyed. So you have a constantly born and die in the cloud somewhere. And this is how cloud native goes. And this is why you need cloud urgently. And I don't say this only because we are the system and we have something like this, like our perfect open telecom cloud. But believe me, you have to think about this topic. Veronika.
So this is what you can take away from our little talk. You need to build small white elephants. You need to balance speed and value, thinking about the things you don't do, and thinking about how you can verify and falsify your value. You need to improve your bottlenecks so that your perceived speed from the outside can be faster. You need a single source of truth, a true single source of truth, which is enforced. There's work with that. You need to make sure nobody does anything outside of the backlog and outside of the code. And this can be work. And you need a real cloud for your speed and for your value.
And don't believe that we all do all the things that we say here on parallel. It is clear that nobody can make all the perfect system that we've shown here. But I found it very, very important that you see the final picture, because only if you see the main direction you have to go, you can find your steps to go there. And we are really keen to help you all going the necessary steps and give you the necessary infrastructures that you may have not to care about some boring things that you don't want to care about anymore. Care about your customer and you will get the value and the speed you need.
Okay, I think we still have some time for questions, 10 minutes. So if there are any questions, we are open to them.
Quick one maybe. What's a real cloud and what is a non-real cloud?
Okay. Can I have the?
Yeah, of course.
Okay. The thing is, if you ask official this question, not me because I'm a little bit emotional, you know. The official definition that usually is taken for cloud is this one from the National Institute of Standards and Technology. And it says a real cloud has these 5 properties. And it is only a real cloud if you have these 5 properties. This unlimited resources thing is even something that we broke with some of our clouds with the systems. Because as soon as you have, if you have to order a computer, if you need more resources, it is strictly speaking not on unlimited resources anymore. It is maybe acceptable for your organization. Think of the adapted speed and what speed you need. If you have a frequency of delivering once a month, you can maybe perfectly afford that you have an order process for getting things. But in a high-frequency delivery world, you want to have a push of a button and get it. And you maybe even want to have higher-level services like a RDS, relational database service or something like this, on the push of a button. Even a Kubernetes cluster on the push of a button. This is unlimited resources, and this is why some of the clouds, and I'm pretty sure most of the clouds you build in your basement have this problem. That you have an ops team which works on 8 ITIL and ordering processes and can only have limited invests and thus limited ways of enlarging the clusters and what you have in your basement. Broad network access is something that you can assume that you don't make something wrong there. Rapid elasticity, yes, this is the way it is with the technologies you have, be it OpenShift, be it Kubernetes, be it OpenStack, be it VMware even. This is there. This is what came in with virtualization and even with para-virtualization. And measured service, because you have a hypervisor, you can measure things you have not measured before. The on-demand thing is also an interesting part. Look, there are non-public cloud providers, especially small ones like Hetzner or something, who don't open up the APIs for you. You may have a clicky bunty, a nice little user interface, click, and so on. But you don't get the API access, which means you cannot have environments on a push of a button, which is usually seen in the cloud community as one of the minor contradictions, but I see it as a big contradiction if you don't have it this way. And I've seen this also in installations where you do it in your basement, because the ops team says, this is too dangerous that you get the APIs. You only get the clicky bunty, the user interface, and this is all what I can give to you because I feel safer if you use the clicky bunty. No, okay. So it is, for me, clicky bunty is okay. Because you see much more things than you see on a command line. But you need the API too for the automation, and without API, automation is even simply not possible. API is the key. And this is why we have decided, for example, for our Open Telecom Cloud, to use an open API, because you're not so dependent then on vendors if you have chosen some kind of standard API. The same way with our container engine, which is Kubernetes, also standard API. It is something that is already deep in the mind of the systems too. Even though we are not usually so much engaged in open source, open standards are already deep in our mind.
Okay. There's another question.
Yeah, this is exactly the way to do it.
Then you have your small white elephant, which you build from scratch, and you run it.
Yeah. Early reality is the key.
The customer knows what, maybe he doesn't, but think that he knows what to want, and how to convince that no, you don't know, maybe we will show you the small part.
The mind shift, no. The mind shift is the following. There is nothing like an environment where you don't show anything. That the policy is early reality, which means nothing has any value what you do without showing it to the customer. This is an attitude which you have to feel. You have to feel uncomfortable as long as you stay on your console and do something and don't see what you're doing. This is the point. And of course, maybe you cannot convince your customer to shoot something to production, but there are helping constructs. For example, you can work with alpha test groups. Find some friendly people and make a production environment already. Don't do something other. Really production environment, always production environment. And give access only to friendly users first. And say, okay, look, this is, because one of the real profound things with product owners is that they sometimes never have seen the system. And as soon as they have seen the system, they will completely say something different what is good for the system, because they don't have something in their mind which looks like relativity theory. They have something in your mind which they say, these experiments are going wrong, so I have a clear indication there's something wrong here and not there where I think the things go wrong. And you need this reality. A system looks completely different as soon as it goes to the wild.
Yes, please.
Can you please go back to the slide? Wow.
Oh, jetzt geht's los.
Too many animations.
There we go.
So, if I understood correctly, between define and feedback, there is the actually coding phase.
Yes.
There's the loop, the complete loop, including industrialization.
So, I think that the question in feedback, primarily the first one, should be asked way before you execute the result of the question at the space. You shouldn't start building something and then you think, okay, I have no idea how I can...
Of course, you need to build the points where you can measure into the product. So you need to think about it before you are actually in the phase. But I ordered it to the phases because this is where you get the feedback from. Maybe that's a little bit of a misunderstanding or isn't so clear here, but of course you need to think, how do I verify and falsify my experiment at the beginning of the project?
Be aware that an experiment has now always two parts, and maybe it's even assigned then to two sprints. You have the part of building the experiment and the observational part. And it is not that you make the observational part somewhere else in the sequence, but the thinking is one-piece deployments, which means you deploy your experiment. No matter what you do, the only way to experiment is to push the experiment, which does not mean, and this is this release thinking, that you have to do it in the frame of a release. You have the allowance to put anything to production. Even experiments don't have to belong to a release because you want to find out something. So you go to the loop once with your experiment, and the feedback goes always in a define phase to make the whole things not messed up. So it is more, and this is why I said high frequency. It is not that you're going with, now I go 10 releases per year, but it's really like a model Carrera car way. You rush around always in this infinite loop, and you do it many, many times. Does this answer the question? What else? I understand if you feel uncomfortable with all these concepts. I do too, but I think you need really to take the path and go for it, and be aware that you will fail. It's natural to fail, and failure is part of the concept.
Yeah. Also, we are both upstairs at the T-Systems booth. So if you have any more questions, you can come and talk to us later.
Thank you a lot.
Thank you.